Hello everyone, I am Satyam Sadhuka. So today we are going to start one of the most fundamental topic of physics, that is motion in one dimension. So before going forward, first we have to understand what is motion, why to study motion. So in your day-to-day life you have seen that a car is moving on a road or a man is just running on a ground, or even you have noticed that the earth is revolving around the sun. So every phenomenon involves motion. Thus, by the help of physics, we can understand motion, we can describe motion mathematically, and also predict the future position of a particle. So, by this we can say that motion means simply movement of a body with respect to time as well as surroundings. For example, if a body is changing its position as time gradually goes, if the body is changing its position from one place to another by keeping its surrounding fixed, so we can say the body is in motion. Now, what is rest? If a body does not change its position with respect to its surrounding as the time gradually goes on, so we can say the body is in rest. For example, if a ball is just kept on a ground, as time gradually goes, if the position of that ball does not changes, then we can say that the ball is in rest. Now, in physics, those quantities which we can measure physically is called physical quantities. Now, these physical quantities are being divided into two types, that is scalar quantity and vector quantity. Now, what is scalar quantity? So, scalar quantities are those quantities which can be expressed by their magnitude. For example, mass, distance, time, temperature, etc. Let me give you a statement that a body is of mass 5 kg. Here you can see this statement is a complete statement, means you can understand the meaning of this statement. Here you can see a magnitude is enough to describe how much is the mass of that body. Thus, by this we can say that scalar quantity needs two fundamental parameters to understand, that is unit of measurement and the numerical value in which the quantity is being measured. Now, what is vector quantity? Those quantities which can be expressed by their magnitude as well as direction. Mark the word, direction is the main thing to describe vector. For example, like if I say that a boy is running 4 km per hour in east direction. That means the boy is running 4 km. This is the speed of that boy. This is a scalar quantity. This term is a scalar quantity. But as soon as I mention the direction here, that is eastward direction, then this whole statement becomes a vector quantity. There are many vector quantities like velocity, displacement, acceleration, etc. Now, to express a vector quantity, we represent it by writing an arrow above a letter. For example, this A is acceleration. Now, to identify it as a vector quantity, we give an arrow symbol above. By giving an arrow symbol above the letter, we describe it that the quantity is a vector quantity. Thus, to understand a quantity is a vector quantity, then we need three main parameters, that is unit of measurement, numerical value, and a direction. Note that direction is a mandatory thing to understand a vector quantity. Now let's go to the chapter, what is motion in one dimension. When a body is moving in a straight path, for example, this pen is moving in a straight path, then the motion of this body is known as one dimensional motion. Okay. In further when we'll go, we'll understand more briefly what is one-dimensional motion. This motion, one-dimensional motion, is all we can also call it as rectilinear motion. This motion, which, for example, the pen is moving in this path, a straight path. Then this motion we can also name it as rectilinear motion. Now, to understand one-dimensional motion, there are certain fundamental parameters which we have to understand first. At first, what is distance and displacement? Consider that consider 2 points, point A and point B. Now I have to go from point A to point B. There are multiple number of ways. Consider that I am going through this path and the path is of length 100 meter. So what does the distance definition defines? The total path travelled by a body is called distance. That means this was my path by which I can go from point A to B. So the total distance which I covered, that is distance which I covered, is equal to 100 meter. If I go from point A to point B, then I again return from point A to point B. Then in that case the distance will be equal to 100 plus 100 equal to 200 meter. In distance, no direction is required. Hence, distance is a scalar quantity. Now, since distance gives us a length of a certain place, so we can say the SI unit of distance is meter and CGS unit of distance is centimeter. We represent distance by writing a capital letter S. For example, here if you can see I have written distance. In short, or to represent distance, I will write here S equal to 100 plus 100 equal to 200 meter. Okay. Now what is displacement? For example, so this was the main path by which I can go from point A to point B. Now when you will move, there means whenever or any body, when it will travel from one place to another, then it will have a shortest distance between each of the points. Here you can see on this direction and there will be a confined direction. You can see on this direction and this is the shortest straight line which I can cover easily. Then hence this is called displacement. So you can see here the shortest distance between the initial position and the final position. So my initial position was point A and my final position was point B, and this was the shortest distance connecting both the points. For final position in a specific direction, you can see that I can go from this point, from point A to point B as in a confined direction, a fixed direction. So we can name it as displacement. Similarly, since a direction is mentioned here, so we can say displacement is also a vector quantity. And remember, since distance does not contain any direction, so we will say that distance is a vector scalar quantity. But since displacement involves direction here, therefore displacement is a vector quantity. Then, as displacement also represents a length between 2 points, therefore the SI unit of distance is meter, displacement is meter, and CGS unit is centimeter. As displacement is a vector quantity, you have seen here that to represent a vector quantity, we have to represent it by an arrow. Therefore, the representation of a displacement we will write by writing a capital letter S and above we will give an arrow. If I give an arrow above, then we will understand that this A signifies displacement. So the next fundamental parameter is speed and velocity. What is speed? So in this diagram you can see that car A at time t1 is in position A. Then as time goes on, at time t2, the car travels a certain distance and come to point B. So by this, you can say that speed is the rate of change of distance with respect to time. Then by this we can say a formula that speed is equal to distance by time. As in speed, no direction is considered, means distance does not require any direction. Therefore, speed is also a scalar quantity. As to define speed, no direction is described. So, the speed is also a scalar quantity. Now, to represent speed, we write by using small letter u or small letter v, as you can see here. Now, as distance gives a length and time in second, so the SI unit of the speed is meter per second and CGS unit is centimeter per second. Similarly, speed is divided into four types, that is uniform speed, variable speed, instantaneous speed and average speed. Now what is uniform speed? So when a body covers equal distance in equal interval of time, then we'll say that the body is in uniform speed. For example, a ball rolling on a frictionless surface. On a frictionless surface, on every time the body covers equal distance, then we will say that the body is in uniform speed. What is variable speed? Consider a ball is rolling on a rough surface. This surface is a rough surface. So when the ball goes up, its speed reduces, and again when the ball goes down, its speed increases. So in every moment, the speed of the ball varies, and due to which the ball covers unequal distance. So we can say that a body is said to be in variable speed when it covers unequal distance in equal interval of time. Now, if a body is moving in variable speed, then the speed at any instant of time, we will say it as instantaneous speed. Means at any, for example, like at this instant, say 2 seconds, its velocity is 4 km per hour. Then we can say that at this instant of time is called this speed is known as instantaneous speed. Now what is average speed? So the ratio, when a body is moving in variable speed, the ratio between the distance covered by the body, when the body is moving in variable speed, the total distance covered by the body to the total time of the journey is called average speed. Now we come to the second point, that is velocity. To describe velocity, we need a direction. Okay, so what is the definition of velocity? The rate of change of displacement is known as velocity. Then what is in real life, what is the meaning of velocity? It means that how fast a body is moving in a particular direction. Then we will say that the body, then we will define it, the body has a velocity. So, as I say the definition, that the velocity is a rate of change of displacement with respect to time. Then the formula is velocity equal to displacement by time. Now, as to represent displacement, direction is required. Therefore, velocity is also a vector quantity. And since displacement also represents a length, So the SI unit of speed is meter per second, and CGS unit is centimeter per second. Now let me say two cases. Case number 1. A body is two car. Consider two car are moving on a road with same velocity 30 meter per second in same direction. Means consider these are two cars moving on a same road. So car A is having a speed of 30 km per hour and car B is also having a speed of 30 km per hour. They both are moving on same direction, for example same eastward direction. Then we can say that the body is having that both the car is having same velocity. As you can see in this diagram that both the car are moving in same direction. So by this we can say that both the car are having same velocities. Now in case B, let's take. In case B, consider this car is moving forward in each direction with 30 km per hour. But car B, after going, it changes its direction towards say southeast direction. A car is going like this in eastward direction with 30 km per hour speed, and car B is changing its direction and going to its southeast direction with 30 km per hour. Since direction of both the body changes, then we will say that both the bodies are having different velocities. How now you will say how we are saying that both the car is having different velocities? Since car B is changing its direction, violating the direction, then we will say that both the car is having different velocities. Now, similarly, as like of speed, velocity is also divided into 4 types. That is uniform velocity, non-uniform velocity or variable velocities, instantaneous velocity and average velocity. Now what is uniform velocity? When a body covers equal distance in equal interval of time, but mark this line, when a body covers equal distance in equal interval of time, but in same direction of the body will be straight on the same direction, then we will say that the body is having uniform velocity. What is non-uniform velocity? Consider a body is moving equal distance in equal direction, but they both are having Consider a body is moving equal distance in equal interval of time, but their directions are opposite. As you can see here, car A is moving on east direction, car B is moving on southeast direction. So both their directions are different. Then we will say that both the bodies are in variable velocities. Now, when a body is in variable velocity, at any instant of time, for example, like if I draw a line here saying that this at this position on 2 seconds, the direction changes. So that any instant of this time is called instantaneous velocity. And what is average velocity? So the total displacement of a body divided by the total time taken is called average velocity. So sorry here, it will be a velocity. So this was all about velocity. Now we will understand what is acceleration and retardation. Generally, bodies do not with uniform velocities. In practical life or in our day-to-day life, every body do not move with uniform velocities. The velocity of the body changes either in magnitude or in direction, or both in magnitude and direction. For example, let me say that you are going through a crowded market with a bike. So at every time your speed will increase, your velocity will increase, decrease, your direction will change. So you will have spaces, so you will go this side, you will go this side, means your direction will change in every moment. So in practical life, velocities do not remain uniform. It varies in magnitude as well as in direction. So by this we can say that the rate of change of velocity, you can see that in every moment your velocity is changing. So the rate of change of velocity with respect to time is called acceleration. So we can write acceleration as so in short form acceleration we write it as ACC dot. This word represents acceleration. So acceleration we can write change in velocity by change in time. So now change in velocity means you will have a initial velocity and a final velocity. Means at initial time you will have initial velocity u, and at final time you will have final velocity v. So at initial time with so to find out change in velocity, then we have to subtract from final velocity with initial velocity. That means final velocity is v minus initial velocity is u. Final time was t and initial time was 0. So acceleration equal to v minus u by t. So this is the formula to find out acceleration. General formula to find out acceleration. By this formula we can derive the most famous equation of motion, that is a. Now take the t this side, at equal to v minus u. Then v equal to u plus at. This equation of motion is the most famous equation in this chapter. This equation is the relationship between velocity and acceleration. Since velocity involves direction, therefore acceleration is a vector quantity. Acceleration is a vector quantity. Now what is the unit of acceleration? So unit of velocity is meter per second and time is second. So by this we can say the unit of acceleration is meter per second square. This is the SI unit of acceleration. And in case of CGS unit is centimeter per second square. This was what is acceleration. Now to explain what is retardation, let us consider two cases. Case number one, that a car is moving with a velocity, with a speed of u at this direction, and the acceleration is acting on the body similar to the direction of the body moving. Then means if the body is moving this side, the acceleration of the body is also moving this side. Then we can say that this body will speed up. That is, body will be accelerating. This the speed of the body will increase. Now in second case you can see that the car is moving with a velocity u at this direction, but the acceleration is acting opposite the direction of the motion. Means the car is moving this side with a velocity u, and the acceleration is acting opposite the direction of motion. Then due to this, what will happen? The speed of the car reduces. That is, the body will retardate. Means the speed of the body will reduce. This phenomenon is called retardation. So what is retardation? We can say retardation that the negative value of acceleration is called retardation. If in question it is said to find out acceleration and you get acceleration as negative value, you get the value of the acceleration negative, then this implies, the negative sign implies the body is retardating. So this is the difference between acceleration and retardation. Then acceleration is again divided into two types, that is uniform acceleration and variable acceleration. So what is uniform acceleration? So if the change in velocity in same interval, if there is change in velocity in same interval of time, then we will say it as uniform acceleration. And what is variable acceleration? If the change in velocity is not same in the same interval of time, then we will say that the body is having variable acceleration. So for today, let it be till this much. On next class, we will go further more about one-dimensional motion. So thank you everyone. Have a nice day.